Hi, today we are going to the topic solid with known cross-section. So let's take a look at question number 1. Let R be the region enclosed by y equals square root x and y equal x squared in the first quadrant. The region R is the base of the solid. For this solid, each cross-section perpendicular to the x-axis is a square. So now, what it means is we have this as R. And then we use it as a base and we build a solid on it. So imagine that you have a baking pan that look like this shape, and then you made a loaf of bread, and then it turned out to be this. If you look down, you look like a leaf, and then if you cut each slice is a square. So if you made a square perpendicular to the x-axis, okay, then you're gonna have many squares. Now, each cross section is a square. Okay, so one more time. So you use this as a baking pan and you make a loaf of bread. It looks like this. If you chop it perpendicular to the x-axis, and each slice is a square. Okay, each slice is a square. Okay, with a little thickness, just like the toast that you have. But if you look down, it looks like this. So now we are going to find the volume of this solid. So same idea. So if you have little square and you put all them together, it's going to make this whole loaf. So therefore, you have your delta x equal to the thickness or the height, and then you have your square base. So therefore, when we find the volume, you're still going to have to find the area of the cross section and times the height. So we say that v equal to integral a to b area of cross section dx, which is the area of the cross section times the height. So we use the same formula that we learned before. The only difference is this time your area of the cross section is a known figure. It's not a notation. It's not going to be circles. It's going to be a square. So we're going to do integral a to b, and this time because it's a square, so it's going to be sine square dx. So now let's take a look at this part over here. So if this is the side, okay, so the side and the side, of course my drawing is not perfect, it look like a rectangle, but if you imagine this is square, square, square. So the side actually is a function of x because it is changing. So if you get this tiny piece over here, you have a small square, and then you get bigger, 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 and then get smaller, 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 smaller. So the side is the distance between y equals square root x and y equal x squared. So the side equal to square root x minus x squared is a function of x, a change. So now we go back over here. So we say that integral a to b. So you're going to have your side square dx. And then what should be the a and b? So same concept, the smallest x value and then the biggest x value. So therefore you are going to have 0 to 1. And your side is going to be this function. So therefore it's going to be integral 0 to 1 and then square root x minus x squared holding square dx because it's side square. So the next step is going to type it into a calculator and then you calculate the answer. So I'm going to make my y1 equal to square root of x minus x squared, and then go back, math 9, 0 to 1, and then you do y1 squared because side square, and then dx. So we got the answer, 0.12857. So we found the answer for question number 1. So now let's take a look at question number 2. Let R be the region enclosed by the y equals square root x and the y equals x squared in the first quadrant. The region R is a base of a solid. For this solid, each cross-section perpendicular to the x-axis is a semicircle. So same idea. You're going to use this as your pen, baking pen, and you're going to bake a loaf of bread. It looks like this. If you look down, it looks like a leaf shape. If you cut them, each one is little semicircle. So therefore, it looks like this. Okay, I'm going to draw a little bit better this time. So you're going to have so now over here, because it's going to be 2D, it's kind of difficult to see the thickness. So basically the thickness is going to be the delta x again. So the cross section is a semicircle. Okay, and the thickness or the height is delta x. So now we are still going to use the same formula. B equal to integral a to b area of the cross section dx. So now this time the area cross section is based on the semicircle. So now look at here. Let's take a look at one cross section. This is a diameter. So the diameter is a function of x. Okay, so the d is the distance between y equals square root x and y equal x squared. So d equal to square root x minus x squared. So we know that to find the area of a semicircle, we need the radius. So the radius equal to square root x minus x squared over 2. So now we will go back over here and we get integral a to b. The area of a semicircle is 1/2 times pi times r squared dx. So now we got integral 0 to 1, 1/2 pi, and then radius squared, holding square dx, and then the radius is going to be square root x minus x squared over 2. And then we type in this in our calculator. So because we know we have a square root over here, it's not going to be a fraction. So therefore, you can type in the whole thing. Or you can factor out the half pi. So now we go back over here. So we have to make my y1 the radius. So therefore, parentheses. Okay, my numerator, square root of x minus x squared. And then divide by 2. So this is going to be my radius. So now we're going to go back to math 9, 0 to 1. Okay, because I know it's not going to be a decimal, so I'm going to type in 1/2 pi, 0.5 pi, and then radius squared, and then dx. So that will be the answer. So we found the answer for this solid.